Hey everyone, thanks for listening. My name's Chris. If you want to get a hold of me, there's an email address and a Twitter handle at the bottom of the screen. This talk is about hacking our way through environments that are hosted inside Google's cloud platform. So we'll start off with a bit of turbocharged training just to cover some security concepts that will be helpful to understand the rest of the talk. And then we're going to go through a simulated breach where we, as an attacker, will work to escalate our privileges locally on a compromised virtual machine. Then we'll try to move laterally throughout the cloud environment, compromising other resources. We'll exfiltrate some data. And as an added bonus, we will actually break out of Google Cloud Platform and over into G Suite, which is Google's productivity platform. So before we get started, just a brief overview on how I got here and why I'm doing this talk. I work on the internal red team at a company that has a fairly large and complex Google Cloud environment. We were in the planning stages for an operation where we were going to simulate malicious activity inside that environment. So essentially the premise was that an attacker was somehow able to establish a low privilege foothold inside the environment. We wanted to know, what could that attacker do? Could they escalate privileges locally? Could they compromise other things inside our environment? And could they access and exfiltrate sensitive data? So that all sounded pretty cool, like a fun operation. The big problem was that I didn't know a ton about Google Cloud myself. I knew a bit. I'd launched some virtual machines and I knew some terminology, but I certainly wasn't what you might call an advanced persistent threat, which is what we wanted to emulate. So I set out on a journey to learn as much as I could about Google Cloud. The first thing that I did was to go out and look for sort of a Google Cloud 101 for hackers, a tutorial on post-exploitation stuff. And I couldn't find anything. It didn't seem like that existed. So as part of my learning journey, I decided to write one myself, and that's all been completed. It's a very thorough sort of entry-level blog to this stuff. And if you're interested in it, you can find it just by typing Plundering GCP into Google. So this talk is based on some of the tactics and techniques from that blog, just a few of them. So if you're actually really interested in this topic, I highly recommend reading the blog because it's quite detailed and thorough, and hopefully it'll come in handy if you're doing this type of work yourself. Just one more thing before we get started. This talk was initially designed to be delivered in person at the BSides conference in Melbourne. And unfortunately, of course, due to the COVID-19 crisis, everything is shut down. So I am recording this from home in the hopes that someone will find it useful. All right, let's get started. So you got a shell. Congratulations. That's the premise of this talk, is that you, as an attacker, have been able to successfully compromise a compute instance running in a Google Cloud environment somewhere. So if you do this type of work, you're quite familiar with this term, of course, but if you're maybe new to this, when we just say got a shell or popped a shell, essentially what we mean is that you've been able to somehow access an interactive console on a remote target machine. There's a few ways that this typically happens. So sometimes it's via something like a web application vulnerability. Maybe you've discovered something like a SQL injection or a file inclusion that's allowed you to execute code. Quite often what I see myself is actually just management applications that are not properly secured that have the ability to access code built in as an actual feature. So maybe something like Jenkins, for example, that has a weak password set on it and is accessible over the internet. All right, so here we are. Our Netcat listener has lit up and we have a shell. Now, where do we go from here? Now, I know myself there have been plenty of times where maybe I've been doing this for a client and I see my listener light up and I get the shell and I jump up and down and I'm excited and I celebrate. And then I take the blue pill and I sit back down and I write a report and I submit the vulnerability. And that's great. And maybe you're working on some type of engagement or a bug bounty where that's the rules and you have to do that, and that's understandable. But I think we can do better, right? I think we can go further, and that's what this talk is about. This talk is about taking the red pill, not stopping at the shell, and doing thorough post-exploitation simulations. So if you work as an attacker and you do these types of engagements for clients or maybe for your own company, or if you work as a defender and you're in charge of sort of coordinating these types of engagements, I highly recommend making sure that post-exploitation is in scope and is done thoroughly. If there's a criminal attacking your environment and they're able to get a shell, they're not going to stop and write a report and submit it. They're going to try to escalate privileges. They're going to try to steal data. They're going to try to cause damage. If we're not doing the same types of things inside our simulations, the very first time we're going to see it is in the wild from a criminal, right? So it's super important to simulate post-exploitation activity, to see what things can be detected, to see what things we missed but maybe need to implement detection for, to see what things we can prevent or stop in real time, and so on. All right, so here we are. We're the attacker, and we're taking the red pill. And there's a few sort of strategies that I hope to drive home in this talk. The first one, and super important, not just in cloud environments, but really any environment you're hacking through, is to think like an agent. So in our world, the agents are the systems administrators or the application developers that have designed the environment that we compromised. Now, if we're able to get a shell on a compute instance, that's not all the instance does. It's not just there with a shell waiting for people to log into it. It probably has an application that's running maybe some services that are doing something. And to do that something, they need some level of permissions. So we need to get in the head of the person who designed the system, try to understand what it's meant to do, what it has permissions to do, and potentially how we can abuse it. Now, when I'm trying to think like the agent that built the system, I find that the most helpful thing for me is to find source code that they have written. So maybe the source code for an application, maybe some scripts that they've written to automate some things. They're somewhere on that system. Find them, read them in detail, get in their head, understand what the system does. The next is this cycle here, which I call enumerate, abuse, and repeat. And typically, hacking is not just super straightforward, right? At least for myself, I tend to work in this cycle. It'd be great if you got a shell on a system and your root and all the data that you're after is just sitting right there in your home directory. But I think that is pretty uncommon. So typically when we compromise some type of system, it has a little bit of permission to do something. So we need to enumerate, we need to figure out what that something is, discover our surroundings, and understand everything that we can do with the permissions that we have. We then need to abuse that. We need to try to do something unintended to maybe uncover data that wasn't meant to be uncovered, or maybe even uncover data that was meant to be uncovered for that application because that's how that application was designed. But uncovering that data gives us more privileges or leads us down another path. And at that point, we repeat, right? Maybe our world has gotten a bit wider right now. Maybe we have visibility to something else. Maybe we understand the system in more depth. We go back and we do enumeration again. We abuse and we repeat. And we keep doing that until we've gained access to as much as we possibly can. At that point, we explore and we exfiltrate. So we have access to everything that we can. We really want to just explore our surroundings, try to understand how a legitimate user of that environment might operate, or a legitimate administrator might operate, and the systems that they might access, the data that they might access, and what's available to them. And we exfiltrate. So exfiltration in a simulation is super important, and I think it's skipped a lot. So as a hacker myself, I know that I like to get root on systems. It's a bit of a hobby of mine, and it's always my goal is to try to get root. But a criminal doesn't care about root. A criminal cares about causing damage or stealing data or tampering with data. So we really need to simulate that as well. We need to find where the goods are and actually remove those goods from the cloud environment. Super important in a simulation so that The blue team can see what happens and try to understand how they could potentially detect or stop that exfiltration as well. All right, let's do a bit of training. So in the Matrix, they have something called the construct. And this is where they load their training simulations. And 30 seconds later, they can fly a helicopter and they know Kung Fu. Unfortunately, in the real world, we don't have that, right? I wish I had that when I was getting started learning about Google Cloud. But as hackers, we have to go out on our own and we have to learn things. We've got to read documentation, we have to read through source code, and so on. So a couple very helpful resources for me when I went to learn about Google Cloud. The first one is Google's official training on Google Cloud, which they host on a website called Coursera, which is an e-learning site. They have tons of classes available with built-in interactive labs, and they're super helpful. That's where I started. I highly recommend it. Also, all of Google's official documentation is great. You can get a trial account on Google Cloud, so definitely you want to sign up on there and start playing around. They give you 1 year for free, and they also give you $300 credits just to spin up systems and try things out. So highly recommend that. But as a part of this talk, we'll just do a bit of brief training as well. So let's get started on that. So what does a Google Cloud environment look like? Now, Google Cloud has something that they call a resource hierarchy, how everything is organized. And it sort of looks like how a traditional file system is laid out. At the very top, there's something called an organization. Below the organization, there's something called folders. Inside folders, you can have something called projects. And projects are what's most visible when you're hacking around inside Google Cloud. This is typically what you'll see as references to projects. Inside the projects, we have resources. Now, the premise of this talk is that we've compromised a compute instance or a virtual machine. That's a resource. But there's tons of other resources as well. So there's compute instances, there's databases, there's object storage, service accounts, virtual networks, on and on, tons of things. And the goal for us as an attacker is maybe we're on one resource inside one project. That's what we've compromised. We want to try to compromise every other resource in that project. And we want to break out of that project and go into other projects and compromise them until we have as much of that organization as possible under our control. Now, how do we authenticate inside Google Cloud, and how do we divvy out permissions at any of these levels? Now, there's two types of accounts. The first is a user account. So this is a human being. So if I work at an organization, I have an account there. It looks like an email address. I can log into Google Cloud via the web browser or via their CLI tools, and I can access things based on the permissions that are assigned to me as a human being. The next type of account is a service account. And service accounts are how we automate things. It's how we do things programmatically. If you're creating an application that runs on a resource and it needs to speak to some other resource inside that organization, it's probably going to be done with a service account. Now, user accounts, we can log into, right? We type in a username and a password, and hopefully we have some sort of multi-factor tied to that as well. But a service account is different. Service accounts don't have passwords. So how do you authenticate as a service account? How does an application authenticate as a service account? Now, there's two ways to do this. And the first is binding. And when we talk about binding, when we create a compute instance inside Google Cloud, we can choose to bind it to a service account. And if you're using the web interface or even the command line interface, this is sort of the default thing that happens when you create an instance. Google wants it to be bound to a service account. And it has actually a default service account that it gives you as well. And if you don't go out of your way to choose non-default options and you create a compute instance, you will end up with a compute instance that is bound to the default service account. And when a compute instance is bound to a service account, it means that literally every single process on that compute instance can authenticate as that service account. And this is super important. If you're creating, let's say, a web application and it needs to speak to a database and you're using a service account to do that, certainly not every process running on that instance with the web application needs that service account. But this is how it's set up by default. So it's very common for an administrator to create a compute instance that has an application that needs access to a service account, but to actually bind that service account to that compute instance so every process can authenticate as that service account. And this concept is super important when we're hacking because it's one of the easiest things to take advantage of. The other way to use a service account is with a key or a key file. And that's just, it's just a private key file. It looks like a text file that you can download and store somewhere. And doing this, you can be a bit more restrictive. So you can have a compute instance that has a web application, and you can install that service account key file somewhere where only the web application can actually access it. Only that local Linux user account running the web service can access that file, and no other process on it can access that file, therefore can't access the service account. So two different ways that we can assign the ability to log in as a service account. All right, hope everyone's still hanging in there. Just a bit more training. So there are a few sort of resources that we're going to be interacting with most as we're hacking through this environment. And I have them on the screen here. The very first is the compute instance. And the compute instance is a virtual machine. It's what we've compromised. Compute instances, when built on Google Cloud, are typically done via images that Google provides, or maybe custom images that you create as well. They almost always have the Google Cloud SDK installed on them. So everything that Google provides has it. And typically, if an administrator builds their own image, they'll have these as well. And there's a set of tools that gives you. The two tools that you'll see during this talk are gcloud and gsu2. And these tools are great. They're Swiss Army knives for interacting with everything inside Google Cloud. If you've done post-exploitation work inside non-Google Cloud environments, like maybe inside Active Directory environments, for instance, you're probably familiar with downloading some type of post-exploitation toolkit to use to sort of hack through the environment, maybe something like PowerShell Empire. Really cool thing about these Google Compute instances is that they come with all the tools you need to do your hacking built in. So you don't need to install anything extra. So super helpful from Google there. The next is the metadata server here up top. Every compute instance has access to a dedicated metadata server, and it's always at this IP address. And basically the metadata server just hosts information for that compute instance. And I'll show you how that works in a second here. It's always available at that IP address, 169.254, 169.254, similar to Azure, similar to AWS. This is how all the cloud environments work. The next are the Google Cloud APIs. So there's a ton of different APIs, and everything that you want to do in Google Cloud involves speaking to some API. So whether you're accessing storage or whether you're trying to query service accounts, etc., it's all done with communication to the Google Cloud APIs. Now, let's just see a quick example of how this works. So let's say that I'm running the gcloud command attempting to speak to these Google Cloud APIs. The gcloud command is actually going to reach out to the metadata server behind the scenes, and it's basically going to go, tell me about myself. The metadata server is going to reply back, and in this case, we have a bound service account. So the metadata server is going to tell the gcloud command running on that compute instance that it has a service account available to it, and it's going to provide it with an OAuth token to authenticate as that service account. Now, the gcloud command does this automatically, but you could just use curl as well. Literally any process on the machine can reach out and ask for that authenticated OAuth token. Now, here I call it a scoped OAuth token, and this is another concept that's super important to understand. So let's say you create a service account inside Google Cloud, and you give it permissions to do everything. It's essentially God mode. It can create machines, and it can read data, and it can do everything in the world. When you create a compute instance and you choose to bind that service account to that compute instance, you can also apply something called an access scope. And it's kind of Google's old style way of doing things. They actually recommend not using this anymore, but it's still super common, and it's actually in use by default. So an access scope essentially limits that OAuth token to only speaking with certain Google Cloud APIs. So let's say that service account has access to create new compute instances just by the permissions that you've given it. You can actually limit that OAuth token to not even speak to that compute API, so that when you're running gcloud commands or when you access that OAuth token, even though that OAuth token is for a super powerful service account, it may be further restricted to the APIs that it can or can't talk to. All right, so the gcloud command has that OAuth token, and it reaches out to the Google Cloud APIs for you automatically and does something, whatever it is. Now, you can do this all manually as well. So you can build these complex curl commands, or you can use gcloud or gsutil to do this for you. So this is when we're doing something sort of manually, right? Using like the gcloud command, for example. But there's a lot more going on with this metadata server behind the scenes as well. So here we show the compute instance and we show the metadata server. Also, as part of that Google Cloud SDK that's installed by default on all the Linux instances, there's a few daemons that are running. And one of them is the Google Accounts daemon. And it's literally just Python code. So you can go out to GitHub and you can view it, or you can find it on the compute instance and see in detail how it works. But essentially, it's constantly reaching out to the metadata server and saying, tell me about myself, right? Every few seconds, it reaches out to the metadata server and says, tell me about myself. And one of the things that the metadata server replies back with that this particular daemon is interested in is SSH keys. So inside Google Cloud, you can define who's allowed to log into compute instances and upload their SSH keys. When those public SSH keys are sitting on that metadata server, the Google Accounts daemon is going to go ahead and create local Linux user accounts based on the usernames associated with those SSH keys that then have access to SSH into that instance. And by default, it actually gives them permission to run sudo and access commands as root as well. So it's super important to know if you're somehow able to drop your own SSH key onto that metadata server, the compute instance that queries it is going to go ahead and create an account for you and set you up so you can log in. All right, now we know Kung Fu. Let's do some hacking. All right, we're going to jump into the first demo. Key points here. Number one, think like an agent. Try to understand what the system does, what they intended it to do. Often the best way to do that is to find source code or scripts or documentation and read through them. And next is to work through this cycle. Enumerate, abuse, and repeat. All right. So let's say we find an application and somehow we've been able to compromise this user's credentials. This is Agent Smith. We're just going to go ahead and log in as him. We see this interesting looking box and we get ready to inject a payload. We fire up our netcat listener, always with the SSL flag, I hope. I want to keep things encrypted. And we've got a bug and we get a connect back. Now here I've run the ID command and you can see that we have this shell in the context of a user called web app. So pretty common for web applications to have some sort of dedicated local Linux account to run as, and that's what we found here. Now quickly, I'm just going to drop an SSH public key into this machine just so that I can SSH directly into it and have sort of a nice clean console. When you compromise a web application in the wild, perhaps there's not SSH open externally and you need to keep working inside that restricted shell, which is fine as well. All right, so we run ID, we see we're the web app user, and we go for a really quick win here and try to run a command as sudo, and it prompts us for a password, which of course we don't have. We're probably not set up to run sudo. We're probably not root. We're a web app user, so that's what we'd expect, of course. So the next thing I want to do here is just look at the configuration of gcloud. So I mentioned this gcloud command is typically installed by default when you're working with a bound service account. When I ran gcloud here, what it did is it actually reached out to the metadata server, and it was able to discover that I have this account available to me called webapp at matrixhq-webapps.iam.gserviceaccount.com. So just by looking at that account name, I can see that inside Google Cloud, they've created a service account named webapp, and we're inside a project called matrixhq-webapps. So this is a custom service account. So it must have been created specifically for this web account. Now, the next thing that I want to do is reach out to the metadata server. You can just see here, I'm just using curl, and see what access scopes might have been applied. And an access scope, of course, could limit the ability that I have to use that service account against certain APIs. Now, when you see this access scope come back that's called Cloud Platform, that's great. That means that there are no restrictions in terms of the APIs that we can communicate with. And this is actually Google's recommendation is to do this, to not apply restrictions in access scopes, and instead to ensure that the individual IAM permissions are properly configured and as restrictive as possible on the account. But when we're working as an attacker, it's nice to see that we don't have to worry about access scope restrictions and that we can at least use the full power of the service account that's bound to the instance that we've compromised. Now, next up, I want to go for a couple quick wins. And these are always the few things that I try right off the bat when I get onside a compromised instance. The first one here, gcloud compute instances list, is attempting to list the other compute instances inside the current project. If you have the permission to do that, you might even have permissions to make some modifications for compute instances. So always check for that one first. That's a goal of ours, is to get that permission while we're hacking through here. And you can see, unfortunately, no, we don't have the permissions. So fair enough. The next one is gsutil ls, and gsutil is a Google storage utility. And when we just run it ls like that, what we're attempting to do is to list all of the storage buckets inside the project. Now, storage buckets often host juicy data, so we want to find which ones are available to us. And again, we fail. We don't have permission to do that. Too bad. So we're using an account here that seems to be a bit restrictive inside this Google project. So we need to find ways to gain access to more privileges. All right, so we sort of start from the beginning of our enumeration. Here there's a curl command that's going out to the metadata server, and it's looking at something called instance attributes. Now, instance attributes are something that can be set individually for this compute instance, and it contains basically keys and values that can hold arbitrary information. Now, we have some interesting looking ones right here. So we've got one called GC bucket, and it has this sort of long bucket name. Now, we ran that command, gsutil ls, previously to try to get a list of all the buckets in the project. We couldn't see anything. Now we see here that there is a name of a bucket. Now, of course, you can brute force bucket names. You can attempt to brute force bucket names, but this bucket name here, it looks like it has some hex at the end of it, and it's long and complicated. There's no way we would have been able to brute force that. So by looking at the instance metadata, now maybe we have the name of a bucket. Now let's see if we can access anything inside that bucket. All right, we can. So that's great. So the permissions inside Google Cloud are very, very granular. So while we did not have permissions using our bound service account to list all of the names of the buckets inside a project, we do have the permissions to access this individual bucket. So this is, again, is very important, why it's important to do enumeration and get in the mind of the agent and try to figure out what's going on. We found an attribute that was manually set that had a name of a bucket that there's no other way we would have been able to discover that on our own. We've listed the contents of this bucket, and now we see something inside there called SSH key, which that looks pretty awesome. Let's go ahead and use gsutil to try to view that SSH key. Crap. That doesn't look like an SSH key. That looks like encrypted data. All right, so maybe we need to go back to the drawing board and do a little bit more enumeration and try to understand what's going on here. So we can curl that metadata server again, and this is the same data we just looked at, but let's look at these other attributes. All right, so we've got a GC bucket, we got one called GC key and GC key ring. All right, that sounds like crypto stuff, and we have an encrypted SSH key, so maybe we're onto something here. Now, when we're trying to get in the head of the agent, again, as I mentioned, scripts and source code are gold. We want to find that. So let's just look at this term GC bucket and see if we can find that inside a script or source code anywhere. So we're inside the home folder of the web app user right now. There's a folder there called Pod Manager, it looks like. That web application that we compromised was called Pod Manager 2, so maybe that's the source code. Let's grep for that GC bucket command inside there, and you can see the grep comes back with some hits. All right, cool. So let's just take a look more closely at the file that it found that GC bucket string in. All right, cool. So we've got a script right here. Now, if you're out hacking through Google environments, you're not going to find this script. This script was written as part of this simulation for this talk. You won't find this script, but you'll find other scripts. And some of the things that we're going to talk about, some of the vulnerabilities or the risks that this script outlines, are things that you will find in the real world example. So let's just sort of go through it slowly. So just reading the comments at the top here. This is a script called by a web app when it syncs contents to dev. It pushes from prod as opposed to pulling from dev, as dev lacks advanced security hardening. So here we have a comment. This is something that the agent, the application developer, has written. There's some comments in there that's really helping us sort of get inside their mind. There's also something quite interesting. So there's a dev environment and it lacks security hardening. So I think that's pretty common for dev environments, and that's pretty cool for us. We maybe want to get into that environment and get into somewhere that's a little bit less restrictive than where we are now. Next, you can see some environment variables for the script being set up. There's GC bucket, GC keyring, and GC key, and it's setting those environment variables by curling the custom attributes on the metadata server. So this is common. So those custom attributes on the metadata server are quite often used to customize variables and to set variables so that someone can deploy sort of a generic script and then use that instance metadata to customize it with variables, which is why it's super important to really comb through that instance metadata. So, okay, that's cool. Next, it says it grabs the encrypted SSH key from GCS. That's what we saw. We saw an SSH key and it was encrypted. Cool. Oh, cool. Okay, now it says decrypts it and it stores it in SSH for the web app user. Uses some long, complex gcloud command here where it uses some of those other environment variables, and it looks like it decrypts the SSH key. Further on in the script, it changes permissions, and then it syncs the production web directory over to dev. Okay, so that lets us know that that SSH key has access to that dev environment. And at the very bottom here, securely deletes all the credential data. Can't have it accessible to web app user. So this is funny, right? So this is a common mistake I think that people can make, is that when they have that bound service account, they forget that bound service account is accessible to every single process on the machine. So any process on that machine can essentially run the same commands in the script and can access that SSH key. So what we can do is we can literally just copy a chunk of this script and rerun the command exactly as it is. And we won't run the parts that delete the SSH key because we want that SSH key. So let's just go ahead and paste that in. All right, so we see a lot of output here. If everything worked as anticipated, we should just be able to SSH now right into that development environment. And here we are. We're in dev. All right, so we've compromised initially the production web server. We've seen that we were a bit restricted in terms of that bound service account that we have, but we were able to do some enumeration. We were able to abuse some permissions that we had, and we've now moved laterally to the development machine. And so now it's time in that cycle to repeat. It's time to start over. It's time to start doing some enumeration. So here it looks like we're also a user called web app. Try to go for a quick win, sudo, still no power to sudo locally. All right, well, fair enough. Let's try some of the quick wins in terms of GCP configuration. So we'll look at the config again here. Now this looks a little bit different than when we ran it on the production machine. On the production machine, the account that it used, the Google service account, was called web app, which let us know that it was a custom account someone had set up. This one, it's a bunch of numbers, -compute at developer.geserviceaccount.com. So I can tell you just by looking at that service account, that's the default service account that Google provides for every project. Now the default service account is a project editor, which means that it has tons of permissions by default. And when you create an instance or a virtual machine inside Google Cloud, if you just go with the defaults that Google gives you, this is how you'll end up. You'll end up with this account. All right, cool. So dev environment, the script told us it was it lacked security hardening, so we can see that that's probably the case here. Let's also look at the access scopes. So we have that default service account, but now we have a long list of access scopes here. So, all right, so that's a bit of a bummer. I can tell you that these access scopes are also the default ones that Google will give you if you don't choose anything. You get that default service account, which is super powerful as a project editor, but you're a bit limited by these access scopes. Now, the most interesting access scope that I find here is the one at the top called devstorage.readOnly. So that means that the OAuth token that's on the metadata server for this instance has access to the storage API for read use. And what that translates to is that it can essentially access all buckets inside a project. So by default, when you create a compute instance, any process on that compute instance can access every single storage bucket. This is the most common vulnerability that I see inside Google Cloud projects, especially because it's a default. So if you have a bucket with sensitive data on it and you spin up a compute instance with all the default settings, anyone on that compute instance can access your sensitive bucket. All right, so let's go for some of the quick wins that we talked about. Now that gcloud compute command, we really want that one because we want to be able to control the compute instances and inside the Google Cloud environment. But you can see here that we don't have access to do that, unfortunately. And the reason for that is because of the scope limitation. You can even see it says request had insufficient authentication scopes. So we're bound as the default service account, which is actually a project editor. But unfortunately, the OAuth token that we're working with here doesn't have access to the API that we need. So, all right, so it's a bummer. So we still can't own everything. But when we run this gsutil ls command, now we're getting some results back, right? So we ran it on the previous machine. We couldn't see a list of any buckets. We had no idea what buckets were in the project. We were able to find the name of one specific bucket inside the instance metadata, which we got into. But we didn't know if there were any other buckets. So we have a list here. They're long, complex names. We would not have been able to brute force those. But we've escalated our privileges a little bit inside this environment here, and now we can at least see the names of the storage buckets. So that's cool. So we've got the web app crypto storage. We've already been in that bucket. We've looked around. We've got images and static, typically nothing super interesting in those types of buckets. But we have one called Ansible backups. Now that looks pretty juicy. So maybe let's take a look and see what's going on inside there. All right, so some typical Ansible stuff here, but we have a folder called credentials. And inside the credentials folder, we have something called credentials.json.enc. All right, let's take a look at that file and see what we got. Crap, more encrypted stuff, right? So this is just what we saw with that SSH key. It's encrypted. Can't access it in the clear, but we know that it's probably something pretty desirable. Now we have a set of limited access scopes in our session here, which we saw earlier. And I know by looking at those access scopes that does not include the ability to speak to the API that can be used to access decryption keys and decrypt that data. So while we have access to some encrypted data on this instance, we can't actually decrypt it using our current permissions with that bound service account. But we still have access to the other machine. So let's try this. Let's just copy this encrypted file from the dev server back onto the production server. So we've exited it out now. We're going to copy it here locally. And here, while we didn't have the ability to actually access that Ansible file, once we move it over, now we have access to the APIs that our agent or our administrator used to encrypt some data. So what we can do is we can actually just run that exact same command we ran before, but run it on this credentials.json file. And as you can see here, the command completed successfully and we have no error. So I think this points out sort of another mistake that can be made inside Google Cloud environment. And the mistake that was made here was that a single encryption key was used to encrypt data across multiple resources that were probably not related, right? Probably that Ansible file should have been encrypted with a separate encryption key that only the Ansible service account had access to. But instead, this web app service account had access to the key because only one key was used to encrypt multiple things. So this is where the enumeration comes in and where the abuse comes in. We want to find shortcuts that administrators took or maybe best practices that they did not adhere to. So let's just look at this credentials file now that we've decrypted it. Awesome, clear text. And this is a service account key file. So at the beginning, we talked about there are two ways to authenticate as a service account. One is to be bound to a compute instance where you're also dealing with access scopes. And the other is to use a key file. Now this is what a service account key file looks like. This service account has been deactivated, by the way. So all you hackers watching this video, you're not going to be able to type this in and authenticate as this account. Which is the first thing I would have thought of had I been watching this video. All right, so we're on a machine. We have access to a service account key file. Let's use this key file to authenticate as this service account. Awesome. Activated service account credentials for an account called Ansible. And it looks like it's in the same project. All right, so we've done some enumeration and abuse, and we keep getting further each time we do this cycle. We now have access to a whole new account via the service account key file. We're going to start over again and do some enumeration. All right, so we look at the config. We're authorized as this account. That's great. And let's go for those quick wins. Compute instances list, and this has succeeded. So this is the permission that we've been slowly edging towards the entire time in this demonstration. So we started at a low privilege instance with very restrictive permissions. We moved over to a development environment that had slightly more permissions. And finally, we've authorized ourselves as this Ansible service account, which seems to be highly permissive. All right, so we know we have access to that compute API. Now there's a command that gcloud has called gcloud compute SSH, and this is essentially a wrapper for standard Linux SSH. But the first thing that it'll do is it will use our SSH public key and put that public key onto the metadata server for the target instance that we're trying to SSH into. So let's go ahead and see how this works. So it's going to generate a pub key for us because we don't have one. You can see on the bottom, it's updating the project SSH metadata. So the first thing that gcloud will try to do is actually apply this SSH key project-wide if we have the permissions. If it fails, it'll just do it for the target instance. So let's see how it goes. All right, it seems to have succeeded. And what we did is we actually used gcloud compute SSH to SSH into the same machine that we were already on. But what happened is it dropped that SSH key onto the metadata server. Now that Google Accounts daemon that's running on this host is constantly querying that metadata server. It sees that SSH key for the account. It allows us in, but it also decides we must be an administrator. So here we go. So now we've escalated our privileges to root on this instance. But there's more, right? It was updating metadata project-wide. So we had a list of other compute instances that were available in this project as well. Let's try one of those. One of them we know to be dev. And again, we're root on dev as well. So at this point, we have compromised several resources in the project. We've escalated our privileges locally on all the compute instances to root. And now we're ready to go even further. All right, let's see how far we can really go here. So in demo 2, we're going to be exploring. We're going to look around, see what's available to us inside this project. And as we talked about earlier, there's a hierarchy. So maybe there's other projects with resources we can compromise as well. And we're going to exfiltrate. So we're going to target the data that looks like it's sensitive, and we're going to get it out of that cloud environment. All right, so here we are. We're on our compromised compute instance. We have escalated locally to root, and we have escalated inside the cloud environment by compromising the service account key file and activating it. All right, so we talked at the beginning of the talk about the resource hierarchy and how there's an organization and folders and projects and on and on and on. So we want to try to understand what's available to us right now. So when we run this gcloud projects list command, we just see this one project here. This is the Matrix HQ web apps that we've been seeing all along. Now, there's usually more than one project inside an organization, so possibly we haven't really escalated our privileges in the cloud environment as far as we can. So let's go ahead and look at the other compute instances that we have available to us. We've already been on the web app dev and the web app prod. Let's see what else here. We've got an Ansible box. We've sort of already compromised that Ansible service account. But now we've got one called Bastion. So Bastion hosts, if you're not familiar with it, are typically used as an entry point into a protected environment. So let's say you only expose SSH to one host, then that would be your Bastion host, and all of your admins or developers or people who are doing work would come in to that instance. And then from there, they would access other resources. So Bastion hosts are pretty cool to compromise because there's other users on those boxes. Now we know we have a root on every instance in the project because we've dropped our SSH public key. So we have a root on that Bastion host as well. And maybe there's other people logged into that Bastion host, or maybe other people have logged in there, and maybe we can access some sensitive data from their sessions. So before we go over to that Bastion host, I just wanted to show you this here. So I'm still on the web app machine, and I'm looking inside my home directory. Inside this gcloud folder, there's a SQLite database called credentials.db. And you can see in there, there's client email, and it's Ansible, and there's a private key. This is the service account key file that I've activated. So while I've activated that key file from some other file on the file system, it actually stored it locally inside my home directory. Now, this is just important to keep in mind as we move to a Bastion host, where maybe there's other developers who have done something similar in terms of activating service accounts to do test and development. All right, so we SSH into the Bastion host. And again, it's just updating the project metadata with our public key. Successful. Here we are. We have an interactive console on Matrix HQ-Bastion. Now let's just take a look at the password file just to see what other users there are on this box. So we can see there indeed are other non-standard users on this box. So people have logged in to this Bastion host. We've got a list of agents, we've got the architect, and then we have our own account that we're using here as well, web app. All right, so let's take a look at our configuration on this box. All right, so we can see it also has a bound service account, and it's that same default service account, which we've already used on another box, and we've sort of already abused those privileges. All right, we know there are non-standard users on here. There are folks who have come into this Bastion host. Let's go ahead and search through the home directory to see if anyone else has one of these credentials.db files. And right off the bat, there we go. All right, so Agent Smith, who we know is running the show, has a credentials.db. All right, so that's interesting. So let's go ahead and just copy Agent Smith's database over to our own local home directory, and we'll fix the permissions on it. And now let's just run the gcloud command again and see what we're authorized as. So you can see here we still have access to that bound default service account, but now there's a star under active next to Agent Smith. Now this is a human account that we're currently authorized as. This is not a service account. So now when we speak to the Google Cloud APIs using the gcloud command, we're doing it in the context of Agent Smith's account. Now, when we run the projects list command now as Agent Smith, we can see that we have more projects available to us. So we've continued to escalate our privileges inside the cloud environment. Now we have a project called G Suite, and we have a project called the source as well. So this trick actually points out an error that a developer or an administrator can make, and that is the assumption that no one else on that compute instance has access to their home directory. So if they run the gcloud command on a shared instance and authorize an account, anyone else with root on that instance can take that account as well. So super important to keep in mind when you're working on your own instances. All right, so let's go ahead and run gcloud to set a different default project. So we're looking at exploring and we're looking at exfiltrating inside the matrix. The source sounds pretty good. So let's just hop over to the source and we will run a gcloud command to see what services we have activated inside this project. So gcloud services list will just give us a list of all the APIs that are enabled in a project. Some are enabled by default, but you can kind of spot things maybe that look like they've been enabled for a reason as well. We're in exfiltration mode right now. Most good breaches that you hear about involve the exfiltration of a database, and we see Cloud SQL here. That looks pretty interesting. We also see Cloud Source repositories, so source code, intellectual property. So those both look like good targets for exfiltration. Let's go ahead and take both of those. And essentially what I'd like to show here is that these tools that we have available to us, especially gcloud, is a Swiss Army knife and can be used for exfiltration as well. So here we're just looking at the list of source code repositories that are available to us using our authenticated account of Agent Smith, and we can see, let's see, there's the production source code for the source, so that looks pretty interesting. We can go ahead and use gcloud to clone that into our home directory here. We've now exfiltrated the source code for the matrix. That's pretty sweet. Let's exfiltrate a database as well. So first off, we list the SQL instances that are available to us, and then we want to list the databases that are available on that instance. All right, we've got an instance here, and we've got some databases, potentials, and programs, and agents, and that all looks pretty interesting for exfiltration. So we can just run some gcloud commands here, and we will automatically dump the contents of the database into a bucket that we're creating. And then from that bucket, we can download that information to our own machine. And there we go, done. So built-in data exfiltration as a function of gcloud. So let's just look at this hierarchy again. We'll look at the top level. We've got organizations and we've got projects. So one organization, we have 3 projects. We've already looked at the source. We've already looked at web apps. We see one called G Suite, and that's super interesting. If there's a project called G Suite, it sort of tips you off that there's some integration going on. Now, Google Cloud Platform and G Suite are two totally separate products. Google Cloud Platform is where we have all of our infrastructure stuff hosted. G Suite is productivity, so it's email like Gmail and calendar and Google Docs and chat and things like this. Just because you have access to one, G Suite or GCP, does not mean that you have access to the other. But integrations can be made. So the fact that we're seeing a project here called G Suite is pretty interesting, and it lets us know that there's probably some integrations going on. So we've done a lot of work in the command line here, but we've escalated our privileges pretty far now. As Agent Smith, we're pretty powerful. So what we're going to do is move out of the command line and into the GUI. And what we're doing is just using the privileges that were granted to our Agent Smith account to add privileges to a new external account that's under our control. So here I'm adding an IAM policy binding to this G Suite project to an email address here called neoistheone2021. 2020 was taken, surprisingly, at gmail.com. Now you can see that's a Gmail address. This is not an account of someone inside this Matrix HQ organization. This is just our own random Gmail account that we've created, and we're granting permissions inside this organization. We're going to give it editor roles, and we'll just do that to each project that we have. Might as well. All right, so those all came back. The output that you saw is just showing sort of the new privileges that are applied on each project. So now that Gmail account that's under our control has access to this. So we can literally just go out to the Google Cloud Platform web console, log in as this Gmail account that we control, and now we have access to the GUI. So there's a lot that you can do inside the GUI. This is where we're in sort of our explore mode. We can automate a lot of it on the command line, but sometimes it's nice to hop into the actual console here and just look around and try to see what's enabled and what things we may want to target as well. So you can see here there's the list of projects that we saw in the command line. We're going to select the G Suite one. Now, when we see a G Suite project, again, we're typically talking integration. So I know just to go directly into the service account area. And let's see what service accounts they have defined. All right, so they have one here called Matrix HQ-G Suite-Automation. And there's a description. It enables automation to G Suite API. So this is custom. This is something that was created by one of the agents. And let's just scroll over and take a look at some of the other column headings. All right, domain-wide delegation. And you can see that it's enabled for this service account. So if you take a look at service accounts in your own target project and you don't see the column at all, it just means it's not enabled on any service account. But when we do see it, it's super interesting because it means that this integration has been created between Google Cloud and G Suite. Now, essentially what domain-wide delegation is that it allows this service account to act as a user account inside G Suite. Now, because we have admin rights inside this project, we can authenticate as this service account. Therefore, we can act as a user inside G Suite as well. So let's go ahead and do that. All right, so the first thing we want to do is to create a key. So earlier when we compromised that Ansible key file, this is essentially probably how that key was created. So we can come inside the console here and just choose to go ahead and create a JSON key, and it's going to download just a text file for us that we can then authorize and authenticate as. All right, so now we're on a separate machine, just a machine that we can control. And there's a script here called GCP delegation.py. And this is a script that I wrote. And if you read through the Plundering GCP blog, there's a link to it as well. And essentially what it's going to try to do is to create a new administrative user inside G Suite using this service account. So we authorize this service account, we act as the service account, and then that service account can act as a user inside G Suite. Now we hope that that user inside G Suite that we're acting as has the permission to create a new Gmail account. So we typically need to find out who the administrators are and just test it out, trying to act as their account to create a new account. All right, so we can just go ahead. We will run the script. We show it the key file. There's a few things we need to know. So I'm going to impersonate Agent Smith because I know that he's an admin in Google Cloud. So probably he's an admin inside G Suite as well. If you really need to figure out who the admins in G Suite are as well, there are APIs that you can also interact with and find that information. But we know Agent Smith's an admin, so let's just target him. And you can see the last switch I'm running here is account neo@matrixhq.net. So this is a brand new account. It's not the Gmail account we used to log into Google Cloud. It's a new account inside G Suite at our target that we're trying to create. So my script, it validates all the access, it attempts to create a new account, and then it generates a random password. This account password has also been changed, so sorry about that, you won't be able to use it. And then the script attempts to make them an admin, and you can see everything succeeded here. So that's great. So that key file we downloaded, that Surface account, definitely has permission inside G Suite, and the G Suite person that we are impersonating, Agent Smith, definitely has permissions to create new accounts. So now we can log into G Suite with this new account that we've created. All right, so we're going to log in with the random password that was generated. And you can see we now have access to the G Suite admin console, which is a totally different thing than the GCP admin console. So let's go ahead and take a look at what users we have in here. All right, so we've got Agent Smith, and we've got the architect, and we've got the account that we created. We want to access Agent Smith's data. We want to read his emails. So we're just going to reset his password. Why not? All right, and now we can add another account and sign in as Agent Smith. And we're back in the admin console, but now we're authenticated as Agent Smith. We can hop over to Gmail. And here we go. We can read Agent Smith's emails. All right, so we've escalated our privileges pretty far inside the Google Cloud Platform environment, and we've broken out into G Suite as well. All right, that's it. So the key takeaways to remember when you are working as an attacker: number one, think like an agent. And this is the most important one, right? Know that the systems that you've compromised were designed to do something. Figure out what that something is. Find the scripts, find the source code, understand what they do. Move through the cycle of enumeration, abusing what you find, starting over. Enumerate, abuse, until you get to your goals. And finally, explore and exfiltrate. Now, all of these are super important for people who are working as attackers, but people working as architects and defenders should really understand all of these points as well, because this is what an attacker is going to do inside your environment. Again, I think it's super important to simulate these scenarios. So if you're working with red teams or doing pen tests or what have you, really try to get that scope to include post-exploitation activities. If you're an admin of your own environment, read through the blog, look at all the techniques, maybe just sort of run them on your own and see what you discover, and try to understand what an attacker may uncover as well. All right. Thank you very much for listening to my talk. Would be super cool to hear from anyone if they are interested in this. So yeah, just go ahead and shoot me an email, or you can ping me on Twitter. Thank you very much.